ఉన్నారు. Today we will dive into transverse waves, longitudinal waves, stationary waves, and beats, which is belongs to 12th physics. Okay, and the chapter is waves. So using FET simulation and other simulation, we can easily understand these concepts with a clear and a fun way. Okay, let's get started. Uh, Let me tell one story. That is, have you ever dropped a stone in a pond and watched the ripples spread? Yes? Or shouted in a temple and heard your voice echo? Yeah? As a child, I loved shaking a rope tied to a tree, watching waves along it. Okay? Sometimes that rope formed fixed patterns. Later, I learned those were transverse and stationary waves. Once I hear two timbre bells ring together, creating a pulsing sound that was beats. Okay, so మీరు ఎప్పుడైనా కాళ్ళు నీరులో విట్రాయారా? అప్పుడు అలైలు ఎలా బదులుదాయో చూసారా? లేదా కోవిడ్లో పిలిచినప్పుడు మీ సవరం మళ్ళీ వినిపించిందా? నేను చిన్నప్పుడు ఓకే సెట్కి కండి ఉండే తోపుని పైన కింద ఆటవాను. అప్పుడు అంగే వేవ్స్ ఫామ్ అవుతుండేవి. కొందిసార్ తోపు సదిల్ పైనలా ఫామ్ అయి నిలబడేది. అప్పుడే తేలిసింది అది ట్రాన్సస్ వేవ్, స్టేషనరీ వేవ్. ఇన్నొకసారి రెండు కోయిల్ బెల్స్ ఒక్కసారిగా రింగ్ అయ్యాయి. ఒక్క పల్సింగ్ సౌండ్ వినిపించింది. అది బీట్స్. ఓకే, క్లియర్? సో బిఫోర్ గోయింగ్ ఇన్ టు దట్ ట్రాన్సస్ వేవ్, we have to know what do you mean by waves. Yeah, waves. Consider any one medium. So suppose this is a medium, this is a water. If you drop a one stone here, it makes a waves. Yeah, already you know that. So consider one medium. It consists of lot of particles. If you give disturbance, that disturbance created at one end. Suppose, so here particles. Suppose if you give disturbance here, that disturbance created at one end to transfer to the other end. That disturbance which carries energy, momentum from one point in space to the another point in space without transfer of the medium is known as waves. Okay, so waves are nothing but it is a disturbance that transfer energy, not a particle, not a matter, only energy and momentum from one place to another place through this medium. ఒక మీడియం ని తీసుకుందాం. దానిలో చిన్న చిన్న గణపదిన పార్టికల్స్ ఉంటాయి. మనం ఒక డిస్టర్బెన్స్ ని ఇచ్చిన ఆ డిస్టర్బెన్స్ ఒక ముఖం నుంచి ఇంకొక ముఖం తాక వెళ్ళుంది. ఈ డిస్టర్బెన్స్ ఎనర్జీ మరియు మొమెంటం ని ఒక స్థానాన్ని నుంచి ఇంకొక స్థానాన్ని తాక తీసుకొని వెళ్తుంది. కానీ మీడియం మాత్రం ప్లస్ ని మార్చకుండా ఉండిపోతుంది. ఇలాంటి డిస్టర్బెన్స్ ని వేవ్ అని పిలువుతారు. క్లియర్? దిస్ ఇస్ నోన్ as waves. Okay. So today we will explore 4 types of waves and see them in action using simulation. Okay, so there are 4 types of wave here: transverse wave, longitudinal wave, stationary wave, beats. Okay, right. First, transverse waves. So before that, I have to share simulation, just introduction for that waves. Okay, so here particles are there. If you give one disturbance like this, you can see particles still there, but waves created. Yeah, that wave carries energy and momentum, which is transferred from one place to another place. This is called waves. You can see that wave format. Okay, right. So transverse waves. In transverse waves, particles of the medium vibrate perpendicular. So this is called perpendicular. Already you know that. Perpendicular to that direction of wave. This is called transverse wave. Direction of wave propagation. For example, waves in a stream, water surface waves, light waves. These are all the example for transverse waves. So transverse waves and a medium low particles wave పోయే డైరెక్షన్ కి 90 degrees లో వైబ్రేట్ అవుతాయి. ఉదాహరణలో రోప్లో వేవ్స్, నీరులో అలలు, లైట్ వేవ్స్. ఓకే, దిస్ ఇస్ a transverse wave. You can imagine that you are going to shaking a rope which is tied to the one end to the tree or some uh, wall. Okay, so if you shake that rope, the waves travels. Already you saw that now. Yeah, the wave travels, but the rope moves only up and down only. Okay, okay, but the rope moves up and down only. So in transverse waves, this is rope. Okay, this is rope. This rope moves only up and down, but the wave passing through this. Okay, so in that case, that is in that transverse waves, there are 2 important points. One is crest, another one is trough. So crest means highest point. This is a crest. Okay, crest means highest point, and also this is the lowest point. This is also lowest point. This is also highest point. Okay, so this is lowest point, that is trough. Clear? So in an transverse waves travels horizontally, but rope moves up and down, forming crest and trough. So crest means highest point, trough mean lowest point. Light waves also transverse wave, already I told you. And transverse waves can travel without medium. For example, light waves. Light waves don't need any material medium to transfer one place to another place. Okay, so it can travel without medium. So transverse phase, particle motion perpendicular to wave motion. So here wave motion, here particle motion. Only particles up and down. We will see simulation related to this. Okay, so forming crest and trough. So crest mean peak point and trough mean low point. Examples: rope waves, water wave, light wave. Yeah, clear? Example: rope waves, water waves, light waves. Okay. Now we can see that simulation related to this concept. Okay, you can see that this simulation. So this is like wave on string using FET simulation. You can select manual mode here and one end fixed. Okay, so you can select fixed end, loose end, node end. But in this case, you have to click fixed end. Okay. Now I can, in this case, the rope tied to the two objects. One is fixed, another one is we can move like this to form a wave. So if you move up and down, what do you observe? What do you observe? What do you observe about the wave and particle motion? Wave మరి particle motion గురించి మీరు ఏమి చూస్తున్నారు? Yes, waves like that. Yeah, waves moves horizontally, but string particles only moves up and down. You can see the string particle, red color particle. Yeah, only move up and down. This is a particle. Okay, so waves moves horizontally, but string particles moves up and down. Clear? Wave horizontal direction లో పోతుంది, కానీ పార్టికల్స్ పైన కింద మూవ్ అవుతాయి. క్లియర్? Is it clear? So wave moving along the string. So this shows that transverse wave. Crest and trough move along the string, while particles move along the perpendicularly. Yes. So you can see that like so. Once again. You can see that particles only move up and down, but wave created this end and transfer to the other end. Now, for like this, okay, right. So these are the transverse wave. Next one, longitudinal waves. Now we are going into that next concept, longitudinal waves. Longitudinal waves. Okay. In longitudinal waves, particles of the medium vibrate parallel to the direction of wave propagation. Okay. So in longitudinal waves, particles of the medium vibrate, but parallel to the direction of wave propagation. Like that. For example, suppose waves goes like this. In longitudinal waves, the medium particle vibrate like this, not at a perpendicular, which is vibrate along with, which is vibrate parallel to that direction of wave. Example, sound waves. Sound waves is the best example for longitudinal waves. And light waves is the best example for transverse wave. Longitudinal waves require any medium to propagate through that medium. Okay. But transverse wave, like light waves, does not require any medium to propagate. Okay. And slingy waves also example for longitudinal waves. So longitudinal waves and a medium low particles వేవ్ పోయే డైరెక్షన్లో వెనక్కి వైబ్రేట్ అవుతాయి. ఉదాహరణలో సౌండ్ వేవ్స్ ఎయిర్లో, స్లింగ్లో వచ్చే వేవ్స్. క్లియర్? ఓకే, రైట్. Like in a transverse wave, there are 2 points, crest and trough. Same like that, in a longitudinal waves, there are 2 points. Here and here, you can see that density of that region, density of the particles. So this is very density. So this is compressions. So this is you can see that the waves spread out. Yeah, this is called as rarefaction. In longitudinal waves, it creates a compression and rarefactions. Sound waves work similarly, needing a medium like air to travel. So for a longitudinal waves, some important points is that particle motion parallel. So this is parallel, yeah, parallel to the wave motion or wave direction. Compression and rarefaction created here. Compression for transverse wave, it is crest and trough. For longitudinal waves, it is compression, rarefactions. Sound waves, example for that longitudinal waves. It's clear? Okay. Now we can see that simulation related to that longitudinal waves. Okay. I can share this screen once again. So you can see that screen. Here you can see that one speaker. Yes. Suppose if we you can hear the sound. Yes. This is wave structure. Now I can click particles because in air medium particles are there. Once, so this is insert condition. Air medium is there, so particles are there. Particles always vibrate about their mean position. Already you know that. But once we on the loudspeaker or once we speak, you can see what happens to that air particles when sound travels. You can see also wave and particles in the same diagram. So waves passing through the medium as well as particles vibrate. Yeah. But what happens to that air particle when sound travels? You can see any one particle. For example, here you can see one particle. They vibrate, so waves travel like this. Yeah, like this. But air particles vibrate parallel to that wave direction. Yeah, not at that perpendicular, parallel. Parallel means you know that, like this. This is parallel. So parallel to that wave propagation. Air particles లో మీరు ఏమి చూస్తున్నారు? Particles vibrate parallel to the wave direction. Is it correct? Yeah. Particles same direction లో మనకి ముందుకు vibrate అవుతాయి. And you can see that compression మరి rarefaction form అవుతుంది. So particles move back and forth in the wave direction, forming compression and rarefaction. This is for longitudinal waves. You can see any one place. The particles only move back and forth. Yeah, మనకి ముందుకు vibrate అవుతాయి. So this is longitudinal waves. Is it clear? Okay. Now I will ask one question to you. How is a longitudinal wave different from transverse wave? Let's think about for 1 or 2 seconds. How is longitudinal wave different from a transverse wave? Longitudinal wave transverse wave కి ఎలా డిఫరెంట్ అయి ఉండి? Think about it. Okay. 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 Let's compare these two type of waves, transverse with longitudinal waves. Okay. So first of all, like features. So direction. So here transverse wave. Here longitudinal wave. Okay. So direction means, yes, perpendicular to wave direction. Yeah, correct. Perpendicular to wave direction. This is parallel to that wave direction. Yes. Yes. Okay. Right. And medium needed. Medium needed. Not always for transverse wave. Yes. For example, light. But for longitudinal waves, medium should needed. Yes. So always needed. Always needed. For example, air, water. These are the medium which should be required for that sound waves. Okay. Examples for transverse waves, we can write uh, rope, rope waves, light waves, etc., water waves, etc. So for longitudinal waves, sound waves, slingy waves, etc. Yeah. Next key features in next key features for transverse wave, crust and shaft formed. Yes. In longitudinal waves, compression and rarefaction formed. Yes. Now it is clear. Formed. ఈ రెండు వేవ్స్ మధ్యలో ఉండే డిఫరెన్స్ లో చూస్తాం. ఓకే. సో transverse wave have perpendicular particle motion, can travel without medium, for example light. Longitudinal waves have parallel motion, always need a medium, example sound waves. Clear? Okay. Now we can go into that next topic, that is stationary wave. Once again, stationary waves. Standing waves are also called as stationary waves. Okay. So these type of waves form when two waves of the same frequency, and amplitude traveling in the opposite direction. Traveling in a opposite direction. Interfere, creating fixed notes and antinodes. Okay. So just to read that. Okay. Stationary waves అంటే రెండు సేమ్ ఫ్రీక్వెన్సీ మరి ఆంప్లిట్యూడ్ ఉన్న వేవ్స్ ఆపోజిట్ డైరెక్షన్ లో ట్రావెల్ అయ్యి ఇంటర్ఫేర్ ఆయుధపట్టు స్థిరమైన, దట్ ఈస్ ఫిక్స్డ్, స్థిరమైన పాయింట్స్, దట్ ఈస్ కాల్డ్ అస్ నోట్స్. మాక్సిమం మోషన్ ఉన్న పాయింట్స్, దట్ ఈస్ కాల్డ్ అస్ యాంటీనోట్స్, ఊర్వతాయి. Clear? This is the definition for stationary waves. There are two waves. Both waves have a same frequency and same amplitude, but they are traveling in the opposite direction, interfere. So, which is create the nodes and the antinodes. Why, sir, these waves are called as stationary waves? Because stationary waves mean standing waves. They don't travel. They create patterns only. சரியா? Okay. Stationary waves don't travel. You can see in that guitar string. And a guitar string fixed ends cause notes and antinotes. So stationary waves interference of two opposite waves. Interference of two opposite waves. There are two key features. One is nodes, another one is antinodes. Nodes means no motion, which denotes that no motion point. Antinodes, which denotes that maximum position, which is opposite to the nodes. Yeah, maximum motion. These are the important points for this topic. Example, guitar string. Okay, guitar string, organ pipe. These are the example for these stationary waves. Okay. Now we can see one simulation for this. Okay. Related to this topic. You can see uh, one wave that is in a red color coming from one end. You can see now the wave coming towards that wall or towards that fixed position. You can see what will happen. So there is a wall or there is a fixed point. Once that wave hits that wall, you can see what happens. Just passing through. Okay, but you can say that sir, just that waves are forming that. Yeah, but it is not. Now you can see that blue color line wave. So these blue color line wave, it is known as reflected wave. Once that coming incident wave, that is red color wave, incident on that wall or fixed end, that wave coming opposite to that incident wave, that is called as reflected wave. So okay, that's why that blue color line is known as the reflect wave. Red color red color line wave is called as incident wave. Okay. So now we have here two waves which is traveling in the opposite direction. Yeah. They both interfere. Now you can see another one is red color wave. This is called resultant wave. This is a stationary wave. You can see that. You can see only black color wave only. You can tell that the black color line or black color wave does not travel. Yeah. It appears to be fixed at some position. That's it. That's why it is called as stationary wave. Just to look at that. So again, I will start that wave like this. You can see that now. Wave coming from one end to another end. Once hit the wall, reflected wave coming. This is a reflected wave, blue color wave. Yeah. Incident wave, red, reflected wave, blue color. Once red color wave and blue color wave interfere, stationary waves formed, which is denoted as black color wave. So stationary waves are characterized by the confinement of a wave disturbance between the two rigid boundary or one rigid boundary and one open end. Okay. This means that the waves does not move forward and backward. Clear? The wave does not move forward and backward. It remains steady at its place. Therefore, they are called stationary waves. Okay. Now you can see there are 2 points. One is nodes, another one is antinodes. Nodes మరి antinodes ఎక్కడ ఉన్నాయి? Where are the nodes and antinodes there? Please look at that. Nodes మరి antinodes ఎక్కడ ఉన్నాయి? ఎక్కడ ఉన్నాయి? So nodes points does not move. Antinodes have maximum movement. Okay. So in this case, this is antinodes because maximum displacement. Yes, this is antinodes. This is antinodes. But here you can see N. That N is denoted as nodes. Nodes does not move. You can see now. Okay. So A means antinode, which have a maximum movement. But nodes means does not move. So you can see that. Nodes and a move kani points. Antinodes and a maximum motion unna points. Is it clear? So stationary waves formed by interference, creating fixed nodes and vibrating antinodes. Okay, stationary waves formed by interference, creating fixed nodes and vibrating nodes. You can see another one simulation later to the once again. So this is a resultant wave. Okay, once that two wave interfere, they create a one wave that is called as stationary wave. That stationary wave does not move; it remains steady at its position. You can see nodes and antinodes here. Where is antinodes? Where is nodes? What is this? And what is this? So maximum position below and above, but nodes here. So this is also nodes. Yeah, nodes does not move. Antinodes only have maximum displacement. So this is antinodes. This is Andy notes. This is notes. This is Andy notes. This is Andy notes. This is notes. Now you are familiar with that. Waves, longitudinal waves, transverse waves, stationary waves, nodes, antinodes. Is it clear? Okay. Now we can move into that next topic, that is beats. Beats. So beats means, okay, before that, I have to ask one question to you. That is, what is the difference between the node and antinode? Node Mari, antinode, Matielo, Amy difference. You can think about it. Nodes means still points and antinodes is vibrating point. Okay. So what is the difference between that between a mode and antinode? Node Mari, antinode Matielo, Amy difference. Clear? Okay. Now we can move into that this topic, beats. Beats is a type of wave. Already I told you. So beats occur when two sound waves slightly sorry with slightly different frequency different frequencies interfere producing alternating loud and soft sounds. This is the definition for beats. Okay. So beats అంటే రెండు సౌండ్ వేవ్స్ స్లైట్ గా డిఫరెంట్ ఫ్రీక్వెన్సీతో కలిస్తే ఒకసారి లౌడ్ ఒకసారి సాఫ్ట్ సౌండ్ వినిపిస్తుంది. అదే బీట్స్. క్లియర్? సో there is a formula for beat frequency because you know that there are two waves which is slightly different frequency. So they have a two different frequency, slightly different. So formula for beat frequency is modulus of f1 minus f2. So the f1 means frequency of that first wave. F2 means frequency of the second wave. So f1 minus f2 modulus, which is known as beat frequency. Example, 256 hertz. Hertz is a unit for frequency. మరి 260 hertz రెండు tuning forks. Yeah. So 256 hertz మరి 260 hertz రెండు tuning forks. You can see that slightly different. Yeah, 256 and 260 only four difference. Okay. So beat frequency 260 minus 256 you will get 4 hertz. So beat frequency 4 hertz. Clear? When two tuning forks, for example, 256 hertz and 260 hertz, sound together, you hear a pulsating sound that is called as beats. The beat frequency 4 hertz because of this formula. Modulus of 260 minus 256, we will get 4. Now we can write important points or summary for these beats. Okay. Beats means interference of two close frequency. Underline that word, close frequency sound waves. Okay. Beat frequency formula F1 minus F2. Yeah. Example, for 256 hertz and 260 hertz, it produce 4 hertz, 4 hertz beats per second. Okay, per second. Clear? Okay. We can see one simulation related to this topic. Wait, I will share the screen. Okay. You can see that two waves. Yeah. Sound waves comes from two sources. From one source, from first source, and there is the orange color waves. Okay, you can take that. And from second source, that sound waves coming from that second source, which is denoted by blue color wave. You can take that. So once they interfere, which is a very, very close frequency. Okay. So once they interfere, they creates a pulsating sound that is called as beats. Okay. Now we can set that frequency here. You can see that for the first wave, we can take 600 hertz. You can take any number, but very close to that second wave. Like for example, this is 500 or this is 502 hertz. Okay, you can take like that. So left ear frequency 500 hertz and right ear frequency 502, 502. Okay, hertz. Now we can play. Okay, right. Take another one value 600, 604. Okay. What do you hear? How many beats per second in this previous case? 4 beats per second. Yeah. So what do you hear? మీరు ఏమి వింటున్నారు? మేము పల్సింగ్ సౌండ్ వింటాము. Yes, correct. Pulsing sound వింటాము. You can take 260 hertz here and here 256 hertz here And now play. You can hear the pulsating sound. Yes, you can increase that hertz value 500, 600, 700, or 100, 100 not to. But in that case, there is a pulsing sound created. Yes. So beats form when two close frequencies interfere. Okay. So beats form when two close frequency interfere, creating alternating soft and soft sounds. Okay. Creating alternating loud and soft sounds. Right. Okay. So now this class summary. First of all, waves. Waves, disturbance that transfer energy, not matter. Yeah. Waves and disturbance. ఇది మ్యాటర్ కాదు, ఎనర్జీనే పొందుతుంది. క్లియర్? దెన్ నెక్స్ట్ transverse waves. Transverse waves. So transverse waves, particle motion perpendicular to wave direction. Is it clear? Particle motion perpendicular to wave direction. For example, rho phase. So transverse లో particles 90 degree లో move అవుతాయి. ఉదాహరణకు string waves. Is it correct? Okay. Next one, longitudinal waves. So in the longitudinal waves, particle motion parallel to the wave direction. For example, sound waves. Yes, clear? Longitudinal waves, so particles సేమ్ డైరెక్షన్ లో ముందు బిందు మునిగుతాయి. ఉదాహరణకు సౌండ్ వేవ్స్. ఓకే. నెక్స్ట్ స్టేషనరీ వేవ్స్. Stationary waves. So stationary waves means interference of opposite waves forming notes and antinodes. Example, guitar string. Yeah. So interference of opposite waves forming notes and antinodes. Stationary wave లో notes లో మూమెంట్ లేదు, antinodes లో అధికం ఉంది. ఉదాహరణకు గిటార్ స్ట్రింగ్స్. ఇస్ క్లియర్? అండ్ ఫైనల్ బీట్స్. బీట్స్ అంటే రెండు నియర్ ఫ్రీక్వెన్సీ సౌండ్స్ ఇంటర్ఫైర్ అయినప్పుడు పల్సింగ్ సౌండ్ వస్తుంది. ఓకే. ఇన్ బీట్స్ alternating loud and soft sounds from close frequency interference. Is it clear? So these are the important points from this class. You can note it down and please read at your home. So now homework. Please try. Draw draw and label transverse and longitudinal wave. Okay. And second question, explain beats with one real life example. Okay. Example. Third question will be okay. Calculate the beat frequency for that mm, for beat frequency for two sound waves. One is 440 hertz and another one is 4 446 hertz. Okay, just to try for these questions. Okay, so transverse wave మరి longitudinal wave draw చేయి craft crust draft compression rarefaction లేబుల్ చేయండి. ఓకే, బీట్స్ ని మీ ఓన్ వాట్స్ లో ఎక్స్ప్లెయిన్ చేయండి ఒక రియల్ లైఫ్ ఉదాహరణతో. ఓకే, రైట్. అండ్ ఫర్ దిస్ క్వశ్చన్ 440 హెడ్స్ మరి 446 హెడ్స్ ఉన్న రెండు సౌండ్ వేవ్స్ కి బీట్ ఫ్రీక్వెన్సీ కాల్కులేట్ చేయండి. These are the homework today. Okay, so any questions, if you have any doubt, please ask me. I will answer you. You can think about in many questions from this topic. Yes, from transverse wave you can think about it. Are the particles of the string moving in the same direction as the wave? In transverse wave, string particles wave direction lono move avudunara. In longitudinal waves, longitudinal wave transverse wave kilo different ayundi. How is longitudinal wave different from a transverse wave? These are some of the questions you can think about it. Yes, and what is the difference between a node and antinode? Node మరి antinode మధ్యలో ఏమి difference? Yes, so why do beats sound like pulsing? Beats ఏంటి pulsing sound లాగా వినిపిస్తుంది. Yes, so these are the some of the question you can think about it. So this is today class. Anybody any question, please ask me. I will answer you. So waves is nothing but disturbance. That disturbance travels from one medium to another medium, one point to another point without particle movement. Okay, only energy and momentum only passes. That medium particle does not move. This is a very fundamental and basic concept for that this topic, waves. Okay, no question. Thank you. Jai Bharat, Jai Hind. Thank you.